So let's get underway. So a very warm welcome to all of you for joining us today. Today is, of course, the third installment of Kaleido's 2024 Cellular IoT Connectivity Series. So if it's your first time with us, it's fantastic to have you with us today. We're looking at security. And of course, if you've been with us already, then you'll have a bit of an idea of what to expect in these sessions. Over the coming webinar, we'll be sharing a lot of new insight with you from the ongoing research that we do here at Kaleido Intelligence, alongside a lot of thought-provoking discussion as well from the team at Keegan. Again, really of the goal of helping to inform the strategies on your side. So a lot of information that we want to share and work through with you in the next 45 minutes. With that in mind, let's move on and take a look at the agenda that we'll be covering today. And we'll go through this first, and then we'll go through an introduction to the speakers. But as I mentioned, today's webinar is all about looking at security and connectivity. And this is all part of the wider educational series that we've been doing under the umbrella of Cellular IoT Connectivity. So a reminder for you, if this is the first time that you are joining one of these series webinars, this stems from a really highly in-depth research that we at Kaleido Intelligence carried out earlier in this year, where we did primary research with 1,000 enterprises worldwide. The goal of that research was really to understand, how is cellular IoT being utilized, being harnessed to help drive innovation, new use cases? What are the challenges that enterprises as customers are running into? So what are the pain points? What are the obstacles they're overcoming? What support do they need moving forward? And so this was a big survey that we did. We looked across different industries, we looked across different technologies. And the whole idea of this is to be able to present these findings to help encourage further education in the industry, to help ultimately move us forward as a collective, as a whole. Today's session, as we've talked about, is really digging into the security and connectivity element. And so what we'll be doing in the first part of the webinar is presenting some of those findings from the survey that are really digging into that area. How are enterprises looking, at security as part of their overall connectivity strategy? What are those common pain points that they're coming across? We'll present that at the outset of the webinar, and then we'll move into the strategic element, the how. How do we address these problems? What are some of the use cases that we can do to help come across that and combat that, for both for now and future-proofing as much as we can moving forward as well. As you can see on the agenda, alongside use cases and discussion, we'll be talking about IoT Safe in particular as well, and the features there, how that can be harnessed as part of the overall connectivity strategy too. And there'll be a lot of discussion, and the team at Keegan will be presenting to us during that time as well. As you can see, we finished with audience Q&A. As always on these webinars, there's a lot of content that we'll be sharing, a lot of discussion, a lot of questions that we always hope will trigger questions at your side as well. And we want to hear those as we go. So to submit your questions as we go through the webinar, please use the chat feature. So again, bottom right-hand corner of your screen, you'll see that lovely chat icon. A very simple process, just open up the chat icon and type your questions in as we go. As with all of these webinars, we try to finish after around 45 minutes or so. Hopefully we'll be able to address those questions live, but if not, we always make a point of following up afterwards. So one way or another, we will get you feedback. Perfect. Well, before we hand over and go through the first part of the webinar, dig into those survey findings, let's give a quick introduction to the speakers that we have, lending their voices and their expertise to the discussion today. So as you can see on the screen, we have James Moore from Kaleido, and then we have Chris Burke from Keegan and B. Hayes the Core from Keegan as well. So some very good voices. And guys, let me invite you to come off of mute quickly and just give a quick introduction to each of your roles for the audience. So we'll work left to right as we see on the screen. So James, if we start with yourself.
Absolutely. Thank you, John. Hi, I'm James. I'm a principal analyst with Kaleido Intelligence, and I work within the connectivity team as well as coordinating a lot of our survey work. So a lot of the survey that's forming the backbone of these findings has been I've been responsible for, and I also look into the various bits of signaling security and so on that we look into at Kaleido as well. So really looking to dig into the security side of those findings as well to go from some of my other areas of expertise as well. Yeah.
Thanks, James. And Chris, I'll hand over to you.
Hi, everyone. It's nice to talk to you all. My name is Chris Burke. I'm the CTO at Keegan. IoT Safe is a subject that's quite close to my heart. I've spent a lot of time looking at IoT Safe, but my history has been at ARM and previously at Community. So feel free to fire me any questions that could be related to IoT Safe, but generally just to the SIM and what power the SIM can bring. Thank you very much.
Thank you, Chris. And then B, yourself.
Hello, everyone. Thank you so much for having us today, John. And I think as a quick introduction, I am VP of Marketing at Keegan. I'm based in the UK, but with a global team and remit. The marketing that we do at Keegan is highly technical and spans, working with programs such as Kaleidos to understand what are the challenges that customers are facing in the field around overall security and particularly securing connectivity, to also working with our partners as Keegan works in a deep partnership ecosystem to solve some of these challenges that customers are facing. So I will come in today and give some examples of how we've been working collaboratively with partners to bring solutions to end-to-end security and around how enterprises can use hardware root of trust towards addressing scalability for their connected solutions. I don't know if many people here would have already been familiar with Keegan, so I will take just 2 seconds to give an introduction about Keegan. But Keegan is a global security leader, and our focus is in simplifying scalable, secure IoT, particularly for manufacturers. But we work extensively in partnership with connectivity providers, module vendors, chipsets, semiconductors, and the wider ecosystem. So when John mentioned that this is all about understanding how we come together as an industry to really serve the needs of enterprises and shape your strategies, we are hand in hand working with the leading names in the industry, over 200 connectivity providers across, our products have supported 2.5 billion SIMs in the field already, and more to come. Keegan is known as an eSIM specialist and particularly as an iSIM pioneer. We're very proud of this pedigree, and we're heavily invested in collaborative standards across the GSMA, the Total Connectivity Alliance, the Global Platform, and more. And Chris will give you some examples of that through our work with IoT Safe. Originally, we were spun out of ARM, as already Chris mentioned. Many of our team have derived their expertise through understanding how connectivity scales through compute platforms. And in recent news, Keegan is also the 2024 Startup of the Year as part of the Mobile Breakthrough Awards recognition. So I'm really happy to be part of this discussion and looking ahead to how we can engage in a conversation around end-to-end security with you.
Perfect. Thank you, B. And likewise from my end, thrilled to have you guys with us here, and looking forward to what you'll be sharing later on in the webinar as well. So, as mentioned, Chris and B will be sharing some insights and discussion and use cases later on when we look at how we address the challenges. But that sets us up perfectly to get into the meat and actually how enterprises are viewing this. And on that note, let's hand over to James. And James, you can take us through the first part of this webinar as we look into what the findings were on security from our enterprise research.
Absolutely. Thank you very much, John. Just first of all, an introduction to the survey itself, just some quick demographics on it. So this was a survey of 1,000 enterprises across a variety of sectors, looking at how they were going to be implementing cellular IoT and what their thoughts were, what their needs were, how they want their connectivity providers to be integrating with the other aspects of their business and that sort of thing. One of the biggest things that we've seen from this from previous years is that there is a far higher level of adoption of cellular IoT. We ask respondents that think that report that they know a fair amount about IoT and their organization's IoT policy, and so we get some cellular IoT adopters and some non, but we've gone from 48% adoption in the first edition of the survey in 2022 to 80% in 2024. So there's a much higher instance of folks actually picking up the cellular IoT and using it within their businesses, and that sort of plays into a lot of the concerns about security and so on, which are quite pervasive within the industry. If we can go to the next slide, please, John. We asked enterprises to talk about how they saw the threats of cybersecurity breaches, and over 80% said that it was quite a high level of concern. It's not something that there are enterprises that are keenly aware that they need to keep everything secure. Well, historically, the IoT has been a bit of a mishmash of security, and it's been sort of connectivity first in a rush to get everything connected without much thought of security. It is top of mind for enterprises when you're thinking about this sort of thing from the end user perspective. And security is seen as quite a challenge as well, and we can look into where we think that on the next slide, please, John. So when we ask what the top 5 challenges were from both cellular IoT adopters and those who don't currently adopt but are sort of looking into it and considering and evaluating, security of devices and environment was mentioned by just under half of all respondents as being on their top 5 challenges for things that they want to address with cellular IoT. And so it's, again, very, very top of mind. One of the things that is possibly worth noting as well, as much as there's sort of concern about the threat of data breaches, it's also the level of concern about security is not necessarily linked to that. So this is just becoming a pervasive understanding within organizations at this point. There's been lots of talk about secure by design and so on within the industry for many years, and it's taken a while for that to trickle down to the end users and the enterprise space to actually get their connected devices properly secure. But that awareness is slowly sinking in, as we can see from this particular piece of data, and it's now something that enterprises actively look for within their connectivity product. If we can see sort of the next slide, please, John. When we asked them what top factors they looked for within their product, and extensive security features was mentioned by over half of respondents. It's something that is considered potentially table stakes by quite a few enterprises, that they won't consider something unless it's already got a fair amount of security on board. So being able to address and talk about security is a key thing from a both positioning standpoint and being able to deliver on that promise as well. If we look at the fourth highest factor on here, that being able to meet specialized requirements, being able to tailor things as well to whatever the circumstances of an individual enterprise is, that's also key. So enterprises are expecting things to be highly to be secure and tailored to their needs, which is a bit of a tight balancing act for CSPs as well. And it's as to where it comes across, we can see that in the next slide. We asked what sort of value-added services the end users wanted, and the ability, and apart from some consultative work on the software side, network threat detection is one of the key points of that, as well as device to cloud integration and authentication. They're seen by almost half of the current adopters that when they investigated their connectivity solutions, that was part of their thinking process. So being able to supply that authentication perspective and the threat detection on the network, so being able to give that security perspective is something that is absolutely key to presenting a connectivity offering. And in terms of how we deliver that, there's as we sort of mentioned, we're going to be talking about IoT Safe in this webinar. eSIM is a key channel for that, and it's already being seen as one of those. If we can have the next slide, please, John. The part of the appeal for eSIM is that it can act as a security anchor. When we asked eSIM users why they chose it, then we've got half of eSIM users here saying that it can be used as a root of trust, as one of the key reasons for them to use it, and it can then be used to do things to encrypt data. It can act for device identification and authentication purposes. It can be used for a range of security options to secure things, and this is it's one, not necessarily the exclusive driver. If you look at, there's also some quite high results from people wanting to reduce costs or reduce operator lock-in. Previously, the operator lock-in has been far and away the best or the most attractive reason to use eSIM, and that's sort of been quite a few of the marketing messages around the technology. But now that folks are starting to understand a bit more about eSIM and wanting to consider the use cases for eSIM in a bit more depth, then security is starting to come to the fore. And that's what we're going to be discussing as part of this webinar, how you can make eSIM part of that security setup and what that means for the use cases for your for within your organizations. And with that, I will hand back to John.
James, thank you very much, and you've set it up nicely, I think, to hand over to Chris as well. But before that, I mean, I think it's quite clear what you've laid out in terms of not just the challenges that we're seeing from the enterprise and how they're approaching this, but also, as you just mentioned, how security built in through, for instance, through the eSIM, can help address some of these as well. So you've teed it up perfectly, I think, to hand over to Chris, and obviously the work that they do at Keegan, helping to enable this, directly with their partners to customers on the ground. So Chris, let's hand it over to yourself, and I'll let you take us on in the how.
Yeah, no, thank you very much, John. Yeah, so perhaps the first thing that we can jump into is why an IoT device would require a root of trust. So firstly, if we think about IoT devices, they're typically doing two things. They could be sensing data and they could be actuating on that data. And when they do that, it's really important that the data that they're sensing is trustworthy. And that introduces this first why, which is signature verification. What we can do with IoT Safe is look at the data that a device is sensing and sign it before we send it anywhere. And of course, also then before we send the data anywhere, we can ensure that the connection to, for example, a cloud is well secured. So we can enable things like DTLS or even standard TLS security from the eSIM. And we also want to make sure that the device hasn't been manipulated in any way by some third party. So that introduces this role of secure boot and attestation. So another solution that we can provide with IoT Safe. Of course, all of this requires a root of trust, and understanding what a root of trust is important too. So the eSIM benefits from a centralized distribution or centralized way of sending out credentials, and we can use that centralized solution to provision keys for IoT Safe. So that comes together and helps us understand the why. So by building on that eSIM security, using standards, using security that's interoperable and everybody understands, we can consolidate the security function on that common piece of hardware. And that's the eSIM, it could be an iSIM, it could even be a standard SIM for that matter. And that opens up these use cases such as chip to cloud exchange with zero trust principles, enabling you to either use in-factory technology to provision some credentials onto a SIM and enable IoT Safe to be used as this cryptographic toolbox to do that, or even in the field, enable use cases as you discover them, post issuance. Next slide, please, John. So IoT Safe essentially is enabling this end-to-end level of trust. It's something we've invested in heavily, so it works across all of our operating systems. It also works very well with our management platforms like our EIM, and it's fully standardized. So you can go to the GSMA's website and you can read the standard of how the applet works. And what the applet brings essentially is a toolbox for the device to call into, opening up a wide range of use cases. So some of the use cases we've seen, as I mentioned, was the DTLS connection, for example, to a cloud. Say, for example, AWS's IoT cloud. We can enable you to connect to that without having to provision some credentials into the device. Instead, they can be provisioned into the eSIM, which is much more inherently secure. And anything in between, such as verifying signatures. We've seen interesting use cases with blockchain and much more. So in terms of the stack, if you look at the bottom left of this diagram, what you end up with is IoT Safe as an application on the eSIM, and you'll typically have an eSIM if you've got a cellular enabled device. And the eSIM communicates to a cellular modem. What we also provide is some technology called the Keegan SDK. So that sits on the device or the rich OS, and that enables you to communicate to the modem and then subsequently down to the eSIM itself. So above that, inside the rich OS, you could have a TLS stack, and we support all of the big ones like Mbed TLS, BearSSL, OpenSSL, and so on. So that when, for example, you initiate a TLS connection, to start the connection, you make a call into IoT Safe for the critical session establishment. But then the rest of the TLS is happening on the device itself, enabling a performance connection and ensuring that whenever we're exchanging data to a cloud, it's happening in a way that's not going to impact the battery life of a device, opening up many other use cases. So on the bottom right of this diagram, then you could imagine that you would have essentially a simple device with an eSIM and a modem and a rich OS with a small piece of software that enables you to talk to any cloud and ensure that any data that you've captured, you can make sound decisions on for whatever you might want to actuate thereafter. And on the very far right-hand side of the diagram, as you look at the GSMA material, you'll see that there's different types of IoT Safe applets. We support both of them, which means that we can support a rich set of cryptographic keys that we can provision onto the device and manage on the device and so on. Next slide, please, John.
Sure. Just before you move on to that, Chris, I just wanted to ask some questions on sort of the interoperability here. You talk about you're talking about the eSIM OS and that side of the management. And I know one of the big nightmares for IoT has been sort of securing interoperability. So I'm curious that you're talking about that this is sort of a standards-based solution. So can you go into a bit more detail on how this is interoperable? Because one of the pain points for eSIM that we've seen from the survey is that a lot of folks think that you can't move you can't change eSIM profiles without changing provider, and there's a lot of lock-in with even within a device that supposedly keeps you free to change operators and so on. So I'm curious to how that architecture has sort of impacted the design here.
Yeah, that's a really interesting question. So there's two sides of that. So you hinted at something there, the friction of changing profiles. And I definitely think that was the case in the past. But as we start looking at newer technology like SGP32 or eSIM for IoT, I think it really removes a lot of the friction for changing profiles. It does this by leveraging the ubiquity of the SMTP Plus or consumer RSP, which you use for downloading a profile onto an iPhone or any of your modern devices, but applies that onto the IoT space with the EIMs. That allows you to distribute not just profiles, but software to eSIM. The other side of the interoperability challenge is how do we ensure that IoT Safe is interoperable? So IoT Safe we've written as a Java card application, which means it can run on any platform or eSIM OS platform that has a Java card runtime environment. And we've already successfully run our IoT Safe implementation, the end-to-end stack, not just on our own operating system, but on other Java card operating systems. And we're very much about ensuring that our technology is interoperable and that we enable our customers to have the best experience possible. And that enables us to just ensure that our customers have a lot of confidence in the way that we distribute our technology.
Sure, thank you.
And perhaps if I just can come in here to add another connection point with the question you posed, James. One of the things that the survey noted was that end-to-end security was really a pain point that was felt widely, as well as when it came to eSIM, it's the interoperability. Now, Chris has already talked about sort of how interoperability is being addressed as the standards move on in eSIM itself. But it is worth also highlighting that actually, Keegan's SIM, eSIM, or iSIM are all certified by the GSMA for manufacture, as well as the secure profile provisioning and distribution. So, you know, what is called the sort of SAS accredited SAS UP and SAS SM. And when enterprises are looking at cellular, what's interesting is that within the SIM itself, there are provisions baked in such that IoT safe, standardized within the profile or within the SIM itself, can allow this standardized approach of creating a robust cryptographic store. Now, typically, if you are non-cellular, you'd be using more expensive systems. They are bespoke, kind of discrete components in your bill of material, which would be typically adding extra cost, not only to implement in the design, but manage on a kind of yearly operations basis. And it also adds complexity to the way you would need to do your overall connectivity management or your device management. So depending on what you're looking at as your use case or your implementation in that digital transformation, I think there are some certain advantages that come in built in with the kind of interoperability being solved through eSIM or SIM in any of its form factors. And then there is the very small addition of the IoT Safe applet that we provide that solves many of these challenges that have been previously felt.
Yeah, I think just to add a small point on that is you touched on a really good point that I completely skipped over, which is the certification from the GSMA, I think really brings a lot of confidence. So today we call this the ESA scheme. So that ensures that there's a good degree of security between both the chipset and the operating system. On top of that, we have numerous validation schemes that we align to, including for IoT Safe. There's quite a rich validation test plan so that you can ensure when you deploy IoT Safe in the field, you have a suite of tests that you can align to make sure that as you deploy it, you're covering all of your bases. Equally so that aligns very well with the levels of accreditations that we do for both in factory and for in-field management of eSIM, which enables us to distribute IoT Safe or manage it in the field when we want to discover use cases, because often you don't really know that you need to deploy a particular key until after it's deployed.
Until you need it.
And the benefit of IoT Safe is you can do that. That's one of the real interesting flexible use cases that we see with IoT Safe.
Yeah, so I think one of the I think drivers for cellular adoption that is rarely talked about, I think, or rarely given enough light, is that by moving to cellular, and we find that, as you've already shown in the survey, and the evidence was from 48% to 80%. I think cellular is finding more and more itself in the mix of all of the IoT fragmented technologies that have been, and there is many of these designs as they move to cellular, actually building on the kind of standards approach provides a way to leverage all of these efficiencies that come baked in, but also future-proof the systems such that you can have availability of robust key management and certificate management should the need arise.
So maybe this is a good segue to then talk a little bit about Open IoT Safe and the manifesto that Keegan has been pushing, and it's a really interesting way of looking at IoT Safe. So what we've been saying is we're introducing this mechanism for simple, unified, zero-touch provisioning. But I think it's important to understand what that means. You can have eSIM in the field, which has IoT Safe with keys populated within it. And that ensures that those keys are stored in tamper-resistant hardware. It's very, very difficult or very, let's say, inefficient cost-wise to try and extract those keys. And that removes barriers to hardware-based security. So instead of having to introduce an additional secure element on your design or risk putting your keys inside the rich OS, which is much easier to compromise, you place those keys into the eSIM, and we help our customers do that. And we've seen a number of customers leverage this technology to then use open source software, and this is enrollment over secure transport, to have a trust anchor to enable you to have your device communicate to a cloud. And this is a way to very, very cost efficiently deploy IoT Safe without having to rely on more traditional ways of managing the eSIM in the field. But with that said, we do a bit of both. So we also have invested in solutions that enable us to manage the eSIM using similar protocols that we would use for remote SIM provisioning, which are tried and battle tested. However, that they come with this other challenge of then or the perception that then you need to be deeply integrated with us and so on and so forth. This really enables our customers to innovate, but still leverage ultimately the high security of the eSIM and IoT Safe as an open standard using that technology. And that's what the Open IoT Safe manifesto is all about. Next slide, please, John. So we've got a lovely little animation here. So as I mentioned earlier, so we could have devices which are sensing environmental data. And we have IoT Safe on an iSIM or an eSIM. And that data is being captured by IoT Safe and could be signed, a signature point that I talked about earlier. And once that data is captured, the device can then open a cellular connection. So this will be an open channel, as we call it in the industry, to enable that data then to be securely transported via the cellular service provider to an IoT service provider cloud. And as I mentioned, as that data has all been signed and the keys to the cloud have all been stored in IoT Safe, we can then ensure that any of the data as it's sent to data analytics and aggregation players is secure and trusted. And once it's all done, the connections are all dropped nice and elegantly, enabling the battery usage and power usage to remain as minimal as possible. And this is all, again, fully standards-based and interoperable and explained in the standards from the GSMA.
Sure, and if I can just add a question into that, that example is an iSIM-based one. Is there any sort of meaningful difference here between iSIM and eSIM? One of the things that's come out with the survey is that there's a minority of folk who are saying they don't want to use eSIM because they're waiting for iSIM. Is there any sort of mileage for that, or a reason to do that on the basis of this sort of a use case? I wouldn't imagine there's any real difference. So if we can do some myth busting, that would be great.
You're completely correct. So we've seen IoT Safe deployed on SIM, we've seen it deployed on eSIM, and we've seen it deployed on iSIM. They're differences of packaging. Now, there are some advantages to iSIM in particular, in that you have a much more clearer bill of materials where you can have the IoT Safe application running on our eSIM OS, which is on an iSIM package. And then, of course, you can have our SDK running inside the rich OS of the iSIM. So that kind of vertical integration does bring you some benefits. But equally, you can run it on an eSIM, and you can have our SDK running on the rich OS and communicating via the modem. So there's no reason to wait for iSIM in the case of IoT Safe. And equally so, we've also seen it deployed on standard SIM without even an eSIM in the equation.
Okay, fab. I think with that, we're back to John, aren't we?
Yeah, we are. Chris, thank you so much. I think it's really valuable to see, like you said, the actual how this can be working, through IoT Safe, and likewise, James, the inputs, with your analyst hat on there, and be your thoughts as well. So I think that's really rich and helpful to aid the discussion. And one of the key things, I'm sure, for the audience with anything like this, when we're looking at new technologies and enablement and how it works, realizing from actual use cases that have been carried out, real world examples, helps as well, right? It makes it more tangible, it makes it more real to us, to what that can look like, practically speaking. So I know, B, that we have a couple of additional slides that you'd like to share now that just, again, can help ourselves, the audience, just to look through and understand, right, this is, you know, how that can look like in practice. So Pete, let me hand over to you.
Fantastic. Well, thank you. Exactly. So Chris showed us a wonderful kind of very simple diagram that we can get our heads around. And what I'm going to present as examples in the next slide are how, say, for example, IoT Safe can support IoT's service platforms, for example, providers or network providers, to really differentiate on end-to-end security. So we have some examples that are publicly available through Keegan.com of innovations our partners have driven to address some real problems their customers or customer segments have been facing. And, you know, I hope to give you a sense of what sort of examples are out there, but certainly there are more that we are constantly receiving demand for. So I think some of the value-added services, as already have been mentioned, have been largely around addressing the pain points of even zero trust provisioning, so in-field zero trust onboarding of devices onto cloud. So if you have 10 million devices that you want to have securely provisioned on your own cloud instance, you know, IoT Safe and end-to-end security, particularly harnessing the SIM, eSIM or iSIM hardware root of trust, can really support simplifying that journey, automating, streamlining, and really allowing to build that authentication. But some of the examples that I wanted to share with you are a little bit different than that kind of more widely felt challenge, and really are some fantastic indicators of direction of innovation that you can take IoT Safe to, working with Keegan. So the first example is with a company called Energy Web, who run a decentralized network that supports a secure blockchain-backed ID exchange for renewable energy sources. So working with our partner Core, we've been able to work on an eSIM on their network that takes the securely signed data streams from devices onto Energy Web, who wrap it around a blockchain and allow third-party publishing services to take advantage of understanding where demand is, where supply is for renewable sources, and being able to allow for, say, for example, equitable tariff management, exchange of demand, and load balancing. So there are many ways in which services can then be built on top of that, with that overall aim to support a zero carbon energy grid. So a fantastic example where you can leverage a SIM or eSIM that is available in devices such as EV chargers, such as solar panels, and many other devices that might connect to the increasingly electrified grid, and being able to drive a very rich app store, if you will, of value-added services, and being able to cut down the time it takes to initialize such services and automate their kind of business model. Then we have two examples from our partner Zariat, and both of these actually, relate to the comment made earlier that you could be using a SIM, you could be using an eSIM, you can be using an iSIM. These are packaging packaging options available to you, but ultimately you're using the capability of the SIM to be to create a crypto store where your credentials are secured. And can allow for authentication in a variety of forms. So the first example is with a company called AdSign, and they are dedicated to understanding how could internet services and user-driven services be privacy protected, and such that exchanges of data are done on your own terms. And so they allow for IoT devices to come into such a mix through IoT device authentication for a very privacy-oriented secure data transfer, such that it is on the user's term that they can leverage IoT services, whether that's your smart lock, your smart home systems, whether that is smart lock boxes for parcel and deliveries, and many more, as some of these services extend to not just IoT, not just consumer, but something in between. And then the last one is a really fantastic example, which highlights sort of the opportunities in future-proofing with hardware-backed security that IoT Safe provides. So we have the example of CryptoQuantique, who have a market-leading capability in quantum safe technology, and working alongside Zariat, they are addressing the challenge that investing in costly hardware secure modules is a barrier to many companies trying out their ways, their transition to quantum readiness. And as we look to kind of the Cybersecurity Resilience Act and many others, we require simpler ways for companies to start their journey. And this is where they take the IoT Safe available in SIM, eSIMs or iSIMs, whichever is right for the customer, as a very viable and readily available and accessible way to get onto their quantum safe services. I think as we see some of the use cases that we discussed with, say, EnergyWeb, who already are taking device identity and further, wrapping it with a blockchain to allow for a decentralized way in which services can be published, we can start to see what some of the other opportunities that become possible with, security already built in. So, James, you made a comment earlier that there's been a rush to just connecting, and now actually security is coming into the fore to understand how it can be securely connected. And this is where there has been a challenge with security in that it's a little bit like oxygen. It's sort of invisible, but once you have security baked in, more interesting and newer models of business differentiation, monetization become available. So a few examples here are, say, smart contracts. So these are potentially, say, automated rules-based transactions that can allow devices and services to transact without human intervention, but taking into account sort of the preferences of the user. Talking of preferences, you can take that to, say, insurance-based usage models where you could have setups of favorable policies that are truly tuned to the usage needs of the consumer, or a service that is tailored to a particular class of car, or the engine class of a car. You could start really differentiating what that could look like, but what also means that it's a very fair and equitable use. Same goes, or same principle goes to actually having business models around pay per consumption. So, being able to only pay for the amount of electricity or the charge time that you've used on an EV charger, rather than having to pay for a block of hours. So, charging only for the resources used, and also doing that autonomously. So removing many of those friction points that mean that consumers are or users are a little bit averse of IoT-based technology. And then Chris mentioned how the data is signed, both within the device. It is secured, hence it's at its source during transit to a network, whether that is a cloud-based network, a mobile network, or an IoT service network. And the provenance within. So this is sort of actually the kind of breadcrumb trail, if you will, that results in an audit trail such that you can meet kind of regulations, you can do ongoing compliance, and largely there's a huge amount of demand within this for avoiding anti-compliant fines and avoiding those risks. So certainly those are, can be integrated within business operations, but also play a larger part in how companies are now expected to, say, provide sustainability and ESG reporting. So again, automating, streamlining, and ensuring unique authentication and robust security is baked in through from the silicon all the way to the cloud. We can see some very interesting use cases, and I think hopefully it's coming across, but I'm a geek and I'm quite excited about, I get quite excited about these types of things, but it really is about, how it is a problem right now. But once we start getting to, here are means in terms of how we can solve it, more opportunities become possible. Now, IoT Safe isn't the only way to do it. Certainly, there have been many other options available, even in the cellular space. But we're talking about IoT Safe here because it improves and radically increases that interoperability, that ability of a company to support a much more diverse set of third-party tools or third-party ecosystems where data streams can be utilized. So certainly there are other models out there, and we would encourage everyone to look at how end-to-end security could be brought into the mix of what they are investing in. But as they look out to these strategies, I think I wanted to present just some early indicators of directions that are really innovative, that we see companies working on, which leverage that full potential of a standards-based security that IoT Safe brings.
Cool, thank you, B. It just feels like some of the way that you're sort of talking through it, it feels like one of the key benefits throughout IoT Safe that doesn't really get presented in this way, if I can put it that way, is that it's essentially a way of ensuring secure automation, and it's sort of one of the overall promises of the IoT to sort of have machines that don't need all that manual handling, that all of those provisioning and so on all happens automatically, and it's sort of at the root of all those kinds of use cases. So it almost requires businesses to think about their processes from the ground up again in some ways, because there's so much in the way of efficiencies that can be made here.
Exactly. And every IoT project I have seen, of course, looks at automation and ease of use and all of that. But the clincher has been kind of scale, right? How do you do that at scale? And I think actually this is a perfect segue for what Chris is going to tell us about, because all of the fantastic things that we kind of saw earlier as examples really are about how do you manage, how do you optimize your costs as well during this automation such that it works for extremely large fleets of devices. And I think Chris's team and our wider colleagues at Keegan have been working on something really exciting that we've just launched last month, but it really does connect how you can leverage IoT Safe in a way where you can also do this with simplicity and scale. So over to you, Chris.
Thank you so much, B, for teaming me up. So we've recently been working on this new technology called an EIM. So this is described in the GSMA standard called SGP32, and it's often referred to as eSIM for IoT. So earlier on, James had a question around some of the friction that we've seen in remote SIM provisioning in the past, particularly probably around M2M or the SGP02 standard. And the idea of eSIM for IoT, in my opinion, is really to improve cost efficiency. One of the things that both operators and OEMs want to see is more cost efficiency, especially in the IoT space. And of course, the performance of managing IoT devices in mass. And one of the key things that the EIM achieves is a profile download optimization. So what this really means is the standard is designed to target constrained devices. And constrained devices could be a device without any user interface. It could be a device with very limited battery, or it could be a device with very limited bandwidth. Maybe it's on a Cat1 business network or something along those lines. And the way that it does that is by building a bridge to the consumer standard where the SMDP Plus is defined, or SGP22. But of course, the consumer standard is designed for our high-end smartphones. And if we were to download a profile, especially a profile that contains IoT Safe, using an SMDP Plus directly, we would find that on a constrained network, we're going to have a very hard time. So our EIM handles all of the translation to do that in an efficient way by using things like CoAP over DTLS, which essentially transfers the packets over a UDP connection. I don't want to get too technical, but essentially that's one of the key things our EIM solves, and that enables us to manage the life cycle of a device, not just in the factory but also in the field. So really simplifies how we can activate profiles, download new profiles, download new applications, and is really crucial for a lot of industries such as smart metering. We can also select a wide fleet of devices and invoke an operation on them. So this is what we call campaign management or bulk device management. And throughout this, security is really at the forefront of everything we do. We consider ourselves a security company, so we really try to ensure that everything that we do, we consider security as a foundation. And that's perhaps a good segue into a question that I saw from Liliana. So the question was, and I'll just read it word for word. Is it possible to enable IoT Safe to a SIM later than a manufacturing? So in the past, or in the early days before remote SIM provisioning, we would have used a technology called OTA, or over the air, and we would specifically use remote applet management to distribute an application onto a SIM. And that's still possible with IoT Safe, because at the end of the day, if you have a SIM that has a Java card runtime environment, you can use remote application management to distribute the IoT Safe application. Equally so, as we moved into the M2M era with the SMDP, it's possible to also include the IoT Safe applet inside the profile and distribute it in that fashion. But as we move into the eSIM IoT era and using the EIM, we can place the IoT Safe applet in the profile and distribute it that way too. One other interesting way that we are distributing and managing IoT Safe aligns with the standard that we're anticipating from the GSMA called the Secure Applications for Mobile. And that allows us to place the IoT Safe application alongside a profile, so that if you change profile, you don't have to worry about any keys being inaccessible. And this is a way that we commonly see IoT Safe used, particularly where we like to position ourselves quite well with OEMs and device manufacturers who want to leverage the security functions of the SIM, even as the connectivity profile changes. So hopefully that answers the question from Liliana too, and happy to move on to the next slide.
Perfect. Chris, thank you very much. I think some really good, rich dialogue there, and you've done perfectly in answering Liliana's question as well, within that as well. There is an outstanding question, Terence, that we'll come to in just a sec. Before then, though, I just want to quickly see, James, if there's any final questions or comments from your end on what the B or Chris have presented, with your principal analyst hat on.
Yeah, I think, well, B's gone some way to answering sort of my main question with this, is that there's talk about using eSIM in a lot of ways as part of compliance, particularly looking at sort of the M2M side and making sure that everything stays connected, and eSIMs are there as sort of as an insurance policy in some ways, and making sure that everything is compliant with particular security standards is key to that. I'm curious as to how far you think that to know that whether IoT Safe is sort of becoming an integral part of those discussions. Is it something that is going to have to be updated as a spec for as those sort of compliance requirements and security requirements increase over time or change? What sort of a conversation that's going to be, and how that compliance framework can be managed within through IoT Safe?
That's a great question. So I do think that there will be continued updates to the IoT Safe spec. I think we're anticipating some work on this quite soon. So Sai Garut, our head of standards, is really he's working on so many fronts on the standardization front, and we're continually looking at ways that IoT Safe can be improved, and that's based on what we're learning and the challenges that our customers are facing in the field. So an example of that with Open IoT Safe was, for example, our manifesto, I think, provided some good guiding principles, but standardization, I think, helps everyone feel confident that those guiding principles have been battle tested. So I could anticipate over time, maybe that we'll see some changes or some revisions to the IoT Safe standard to reflect what we've learned. Equally so, on the non-open IoT Safe way of managing the applet, I think that there's some interesting projects that we've embarked on that some of what we've learned, I think, could be standardized, because it's really benefits that we can bring to the industry as a whole. One of my real concerns is that we'll wait until there's a huge issue, data leakage, or devices that have been commandeered before we take this seriously. And I can anticipate that the GSMA is in a really great position to standardize and to ensure that IoT Safe is considered from a regulatory perspective as a good way of introducing security. And standardization, I think, is definitely a good pathway to do that and make sure that everyone's on the same page.
Mm-hmm. And is that going to ultimately cause something of a legacy problem? I know several industries will want to keep devices in the field for like 10 plus years and the like. And if you look at just eSIMs being embedded into cars, you've got huge lifespans there. Is IoT Safe a framework that can stand those sort of firmware over-the-air updates, or are we going to see a kind of a trail of previous versions and different versions of that security implementation going forward?
Definitely, IoT Safe is we can update it over the air using a large number of different patterns, such as OTA, as I mentioned, or we can even reuse remote SIM provisioning. And of course, for particular ways of using IoT Safe, we can ensure that whenever we distribute keys to IoT Safe, we do that on a regular occurrence. So one of the things that really concerns me with eSIM in particular is that we often would distribute a certificate onto the eSIM, and it would stay on the eSIM for 10, 20 years. And that's kind of against a lot of NIST guidance, for example. With IoT Safe, we can ensure that we regularly rotate those keys and make sure that the firmware over-the-air update of IoT Safe happens, and then those keys are reprovisioned onto IoT Safe securely, so that end use case, the security is left paramount and is still remains robust.
Yeah, and a lot of IoT Safe is built on the really tried and tested principles that have kind of been safeguarding the internet. You know, our sort of TLS sessions and things of that nature are kind of what this extends upon. So I think it is kind of built on very robust foundations. And as Chris mentions, of course, there is work for us to do in the industry to support some of the longer term evolution of IoT fleets that we will see, but certainly it is well doable in kind of how it's been constructed is quite a robust architecture.
Cool. Okay. And I wanted to just before we close, wanted to just one question from Terence. He was asking about definitions about IoT moving into cellular, and is IoT and cellular and that sort of thing. They're not necessarily exclusive terms. The Internet of Things can operate on protocols other than cellular. I think the best example of that is the LoRaWAN low power wide area protocol. And another example is Wi-Fi as well. So because Wi-Fi is not cellular, it purely functions on just on the local networks side of things. But there are plenty of IoT devices that will operate on those protocols, not touch cellular or need a SIM as such. So cellular just adds another layer of standards and security, as we're seeing, to some of those deployments in a way that technologies like Wi-Fi don't really.
Yeah, you covered it well. I think the question might have been stemming from a comment I made about more and more cellular finding itself within the mix of technologies. And I think, the way I would just suggest everyone thinks about is that you've got licensed technologies and unlicensed technologies that you can have in the mix. But ultimately, we are starting to enter into an era of IoT where manufacturers or any enterprises want to invest in one product that is actually serviced or services a global customer base. So, you necessarily don't expect that a car brand that you would expect services from in Germany would be very different as soon as you drive over the border in France, or that is something that obviously is only possible with cellular, but cellular still is about 26.8. I should really be looking to James on that, but 26.8% of IoT, whereas things like there are mesh networks and RF networks, things of that nature that also have been used as essentially stepping stones towards the sort of full global range and resiliency, and particularly standardized security that cellular brings.
Perfect. James B, thank you so much. And hopefully, Terence, that gives you a good answer to your question as well. So we're going to have to draw it to a close there, guys. But hopefully that's been a really good, I guess, webinar for you in terms of both understanding the view of the industry towards this, but then also the discussion around how we can help address it. A couple of notes that's related to this webinar, of which a recording will be, a link to that will be sent to you following this event. There will be a white paper available as well that digs deeper into it. That's part of all of the continued education that we want to be given around this topic. So keep an eye on your emails. You will receive the links to those in the coming days. And I'm sure I can speak for B and for Chris and for James to say if there are other questions that you have as you digest the findings and discussion. If you want to discuss further, they'd be more than happy to engage with you. So please just reply to the mail feeds that you receive post-event, and that's a conversation that we can keep going. But for now, we'll say a really big thank you for joining us today. Chris, B, James, guys, thank you so much for your inputs and your presentations and thoughts as well. Really highly valuable. But we'll say goodbye to everyone for now. Stay well, and we hope to see you again soon.
Thank you so
Fantastic.
much.
Goodbye.
Thanks for having us.
Bye.
Thank
Bye-bye.
you. Thank you, everyone. Bye.